Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this learning experience brought to you by Mezmo. My name is Cody, and welcome back to Techstrong Learning, where we have an exciting presentation today. Before we get things started, I do have just a couple of housekeeping notes I'd like to cover with you. First of all, today's session is being recorded. So if you miss any of our discussion, if you'd like to rewatch later or share with your team, you will be receiving an email with a link to access the recording on demand. If you'd like to engage with us today, there are a couple of options to do so. The first option is the chat tab on the right side of your screen. If you see that chat tab, I'd like you to let us know from where in the world you are tuning in. Now, if you have any questions, we want you to send those questions into the Q&A tab. Sending in your questions helps us keep track of them, and we just want to make sure we answer as many as we can today, so be sure to send those in as you have them into that Q&A tab. We will have about 3 polls that we'll be launching throughout today's program, so keep an eye out for those as they pop up. And if you jump over to our handout tab, you'll see there is a resource there for you, so feel free to grab that at your own leisure. Finally, before we close things out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around to see if you're one of our lucky winners. So the topic today is Observability Optimized. 5 steps to telemetry transformation. And I'm joined today by Bill Meyer, Principal Solutions Engineer at Mezmo, and Kevin Woods, Director of Product Marketing at Mezmo. So Bill, Kevin, thank you both so much for joining us today on Techstrong Learning. Kevin, I'm going to kick it on over to you to get us started. Thanks again for being here.
Great. Thanks, Cody. And thanks, everybody, for attending today. I'd like to just mention a couple things about the agenda. Just to start, I'll have a few comments on helping us define what a telemetry pipeline is and what Mezmo does. And then after that, we will hand it over to Bill Meyer, who will carry the major part of the presentation, which is about optimizing telemetry data using a 5-step process. So just to get started here, what is a telemetry pipeline? Mezmo is an established vendor in the log analytics space, a little bit about us. And over the years, as we developed many customers in log analytics, we found and learned that a larger problem in solving for log analytics was becoming the telemetry data itself. The complexity, the cost, the difficulty of managing the sheer volume of telemetry data was impeding progress in log analytics. And so naturally, we expanded our effort at Mezmo to solve the telemetry problem broadly. And you can sort of see a picture of that here. We have all of these different telemetry sources on the left. We have what we're really trying to do on the right, which is observability, monitoring, alerts, all of those sorts of things. And then solving for the middle problem, the complexity problem, transforming routing, testing first that data, and solving that is really what Mezmo is all about. So we see these challenges in telemetry today. And to start, we have a poll question for you, which is telemetry data is a pervasive problem, which many of our customers have challenges with. What is your challenge in particular? If you could pick 2 of these: lack of understanding of the telemetry data sources and structure, too much data, unable to optimize or reduce, data is complex and unstructured, the observability platform costs are too high, or we have runover, outages, telemetry contains sensitive data, or it's hard to manage or automate data optimization. So if you would just please select 1 or 2 of those, that would be great. So I'm starting to see some results come in, and it looks like data is complex and unstructured is the biggest problem by far. Many of you selected some of the others, but that looks like that's a big problem. So that's great. That's what we're going to talk about today. Let's move on to the next slide, which is what some of the discussion in the industry is. This is from Gartner, and so they have a report out that we'll talk about in a minute that defines telemetry pipelines and helps users to understand what a telemetry pipeline can do for you and what its advantages are. In the Gartner definition, what they say is telemetry pipelines, sometimes called observability pipelines, provide a uniform mechanism to manage collection, ingestion, enrichment, transformation, and routing of machine data from source to destination. These solutions can be consumed on a self-managed software as a service basis or on a hybrid basis. Telemetry pipelines may be standalone products or part of the vendor's broader portfolio of monitoring solutions. In the next slide, Gartner talks about some of the benefits and capabilities of telemetry pipelines. So first off is supporting ingest with agents or APIs, enriching or giving the data business context such as location, names, or other dimensions can be brought in. Converting the text into log data such as JSON format, or converting numeric fields into metrics, masking sensitive information. Those are some of the other functions. And then finally, routing the data to its destination, observability or analytics platforms. And sometimes that data is routed to multiple locations. I want to mention here that there's a Gartner report out called Innovation Insight: Telemetry Pipelines Elevate the Handling of Operational Data. You'll be getting an email from us, and if you'd like, I would recommend that you request the report. We can make it available to you in its entirety. And that report covers things like strategic recommendations, planning assumptions, the pros and cons and risks of telemetry pipelines, alternatives to telemetry pipelines and recommendations, as well as a list of representative vendors. So watch for our email, and when you get that, please do let us know that you'd like that report. And now we have one more poll question that I'd like to go to. Why did the telemetry pipeline go to therapy? And we have a few choices. It couldn't get over its past relationships with 404 page errors. The constant data loss was causing bites of depression. It had a recurring nightmare of being stuck in an infinite loop, or it wanted to find inner peace in its data flows. So please pick your favorite answer. It looks like none of the above is a popular one, and that's correct. The answer is it was tired of bottling up its bite-sized emotions. So with that, I'm going to turn it over to Bill Meyer, who is going to talk about a telemetry pipeline not in therapy.
We're going to talk about a telemetry pipeline in production. So yes, good day, everyone. My name is Bill Meyer, and again, I'm a principal solutions engineer here with Mezmo. Prior to joining Mezmo, I was with Splunk, evangelizing their Splunk observability stack. Prior to that, I was with Grafana. So I've been doing observability for quite some time now. And, you know, the whole genesis of this webinar and this talk track is really to kind of focus on newcomers to the telemetry pipeline space to help get them familiar with a prescriptive approach to how do you go about optimizing your observability stack. And the idea is that, you know, it used to be database licenses were the most expensive license in the enterprise. Nowadays, it's your observability tooling. And we want to be smart about the data that we are actually passing to our observability tools, because not all observability data is high value data. Some of it is just noise that we want to reduce. There's others that we can extract meaningful insights out of. Maybe there's some information captured in a log line that is better suited as a metric. So we'll kind of step through some of these examples using a real world application and apply these prescriptive 5 steps that anyone can take and apply to their own specific environment and achieve some of this optimized observability. So to get started today, I want to set a little bit of context. Oops. Just to first, paint a picture of, the example reference application that we're going to be using, because we are going to get hands-on with this. We're going to look at some logs, some information flowing out of our sample application. Many of you are probably already familiar with the OpenTelemetry demo. It's a sample microservices application that can be used. It's written in a number of different languages, uses different services. Each emits different types of telemetry. Logs, metrics, traces, whatnot. Some of it's useful, some of it is just kind of chatty noise, and we'll kind of talk through how we can actually go about addressing some of those different conditions. But I did want to kind of step through this real quick. Today actually is August 30th, and it's going to be the last super blue moon of the year up until 2037. So as normal, I'm kind of behind the curve, and so I'll come out to my favorite, e-commerce website where I can go and buy a telescope and take advantage of their 1-minute shipping. And so I'll go ahead and throw a number of these telescopes into my shopping cart, and then I'll go ahead and place my order. And as I was interacting with this particular website, these different services comprise, just different capabilities, things like a checkout service and a payment service and so on and so forth. There's even an ad recommendation service. We can actually use a telemetry pipeline to explore the information being output by these different services and hopefully elevate some insights that we might be curious about as an SRE, for example, wanting to understand how these services are performing in production and just do so in a real-time fashion without ever having to store the data. It's important to note that with our telemetry pipeline, we are streaming the data from the source to the destination. We don't actually store it. We just operate on it as it passes through the system. So with that kind of context, let's go ahead and kind of take a look at these different steps. And so the first step is really filter out the duplicate and extraneous events. So there's a lot of noise coming out of logs. Sometimes it's meaningful only to that developer. Sometimes it's coming from a third-party application or service that really it's out of our control to do something with that. Or maybe it's a legacy application that no longer has a developer available to go in and modify it, but it's still producing that noise. That noise can be extremely distracting, and it can cost obviously quite a bit of money to have to retain that in our observability tool. So really the first step is just to get rid of these extraneous events that we just don't care about. And so let's take a look at example of how that looks using that OpenTelemetry demo application. If we actually look at the system logs that are flowing through there, we have a combination of both Kubernetes logs, container logs, the application services themselves. And we notice one in particular, this DNS resolution failed, seems to be spit out quite a bit. And as we look through this, we really want to get rid of that noise. It's coming from the OTel collector itself. We can't actually do anything with it until they actually solve that issue. But we can use a telemetry pipeline to intercept that message as it's flowing from the OTel collector over to the observability tool that's going to consume it to basically get it out of there before it ever reaches the destination. And so we can use a telemetry pipeline with a filter processor built in. And I'll show you an example of what this pipeline looks like here in a minute. But the idea is that we can use different processors to operate on the data as it's moving through the pipeline. And so in this case, we're actually using a filter processor. The action will be to actually drop this event. So that matches this criteria. And in this case, we're looking for this SREs success message. And if it matches it, just drop it. All the rest of the messages will pass through it. The net effect of this is that in this particular example, we've actually reduced the log output by 50%, just eliminating these messages alone. But probably the bigger benefit is that we've now cleaned up some of the noise. And so if we extract, we get rid of those noisy messages and look at the results, we can focus on just the information that is meaningful to us. So that's step one, cut the noise out of your telemetry stream. Step two is now that we have that, it's kind of filtered down to just the raw information that we're looking for. It's a common pattern to actually route the full fidelity copy of the log out to your own storage location, whether that's cloud storage or somewhere else, just so that you can have it to be able to recall it later for either auditing purposes, or maybe you want to play back an event that happened and maybe triage the situation. A telemetry pipeline is ideally suited to be able to just take a copy of all the telemetry that's coming into it, route it off to low-cost storage, and enable you to be able to pull it back at a future time. So that's step 2, is route the data. Step 3 is really starting to focus on the data that you're collecting itself, and that's really kind of coming down to trimming the events. You would be amazed at how much null or empty values are actually being tagged for every log, metric, or trace that's being produced. There's tons of attributes in there that just don't have values. Many of the values you probably don't care about. It's not going to help you solve a problem. It's not going to help you reduce MTTR. But it's being captured and it's being sent, and you're being charged for it in your observability storage. So an observability or a telemetry pipeline is a great way to actually eliminate that. We can also change the format of the event. So oftentimes, log lines come in and they're in unstructured format. We can use a telemetry pipeline to reshape that log line, turn it into something that's more machine friendly, like a JSON payload. But those are kind of some examples of where we want to start trimming those events. Taking a closer look at a metric reduction example, this one highlighted line right here is the actual metric itself. So it's a add_request. So that's the number of ad recommendations that we were seeing in our e-commerce app. The value, the rest of this is all the labels being tagged to that metric. And so as we start to kind of look through some of this, we see things like the OS description. I don't know if I really care what OS is running inside the container that this service is running in. I certainly probably don't care about the process runtime description. That's just a long string that just gets stored. I don't care about that. So there's a number of attributes here that we've identified that we want to get rid of. We can simply use a telemetry pipeline to basically drop those additional attribute fields and then just pass on the metric in a cleaned up fashion. In this particular example, just doing that much alone will reduce that metric size by 25%. Plus, it just helps me focus just on the information that I care about. So with that, Kevin, do you want to read the next poll question? Or I can read it. So what percentage of your telemetry is tags versus data? So thinking about that telemetry example that I just showed you, how much of that is actually tagged versus the data itself? A, over 75%, B, over 50%, C, less than 50%, D, less than 10%. We don't have tags in our event data, or F, I have no idea because I don't look at it. So let's go ahead and allow those poll results to come in. Okay, good. A good number of you saying I don't know. And that's a pretty common pattern. One of the first things that we like to do when we get started with the telemetry pipeline is have your data being sent to the pipeline and then explore that data. Look at the information that's coming in. You can open it up, and I'll show you an example of this where you can actually see the log line or the metric itself, and then look at all the additional metadata that's being tagged to that, and then decide, is this something I can live without and I can eliminate it, or I can pass that on because I know I'm going to use that downstream somewhere. Okay, very good. So moving on to step 4, condense events into metrics. And this is kind of where we really start to shine. I think a lot of SREs and business owners really kind of start to take notice, because if you think about it, there's tons of information stored in log lines. Oftentimes we have applications that were written long before modern metric ingestion tools became available. So there's information, CPU, room temperature, IoT situations being written out to a log line. And that information might be better captured as a metric that could be more actionable. And we want to use a telemetry pipeline to extract that information and convert it into a format that can be either viewed in a dashboard or alerted on based on trending information. Whatever your observability tool is expecting, this is a good place to actually do that conversion. And so, metric formats also tend to require a lot lower compute resource and storage resources to actually retain than log files. Oftentimes, we see a single log line that's repeated hundreds of thousands of times, and only a single 1 or 2 values actually change in the log line. Rather than store the entire log line, convert it into a metric, pass the metric on, and just discard the log. You'll be able to optimize your observability investment much better. And we can take a look at some examples of this. Again, going back to the system log example, where we have both the system logs and the application logs mixed together. It's just a lot of noise. If we filter out the system logs for a moment, we start to get a little better clarity as to what our application services are producing and things that we might want to be concerned with. Looking through this, we can see the order placement and order confirmation. We also have a concern here because we notice that we're passing credit card numbers in clear text to our log lines. This is, again, another common scenario. You'd be surprised how often this happens. PCI, PII, PHI, healthcare organizations oftentimes run into this situation where they have information being put in the log lines that they need to clear or remediate for compliance reasons. And so compliance might be one example, and then maybe we just want to track the number of products and the quantities that are being stuffed into shopping carts. And so there's some useful information here that we'd rather extract out of a log line and put it into a metric where it's more meaningful. And so we can actually address the first need, which is identifying that credit card situation. And so we'll define a processor in our pipeline. It's called a filter processor. It's effectively looking for a credit card number matching a regex, which is essentially a credit card number. If we match that, we're going to go ahead and pass that on to the next step. And the next step, we can actually do a couple of things. First, we can encrypt the credit card number so that that credit card number, before it leaves the telemetry pipeline and lands in the observability tool, is now encrypted. We could also choose to just simply mask it out if we just didn't want to retain that information. We have the option of doing both. But we're also, you'll notice, creating a metric out of that event. And so we're creating a new metric called PCI violations clear texts credit card. It's an incremental counter, so we're simply counting up the number of occurrences that we're seeing this credit card number showing up in our telemetry stream. And so when that reaches our observability tool, we can create alerts, we can dashboard that information, and we can see trend lines. Are we trending up? Did something happen? Did something get pushed to production that is now exposing this information? And that's something that we immediately need to address. This is a way of capturing that insight out of the stream and actually making it available to us. Another example, again, like I mentioned, is the business insights. And so, if we want to track the number of products that are being placed into the shopping carts, we can use a filter that simply looks for that particular log line. And then you can see that we're using a parse processor that will match via a regular expression, looking for this product ID and its quantity and its number, and then the quantity and the number of items that were being placed. And so using a regex, we can actually extract just the information that we're interested in. And then again, we turn that into a metric, and that's just a metric of a shopping cart quantity, so that we can send that off to our dashboarding tool and visualize that. And yes, stick around. I will show you the dashboard where all of these insights are made available. I think you're going to like it. So let me kind of finish this out, and then we'll take a look at the live session. The last step of the 5-step process is really driving down that operational expense. It's not something that's often thought about at the front end, but on the back end, it really kind of starts to make sense. If you think about the amount of effort that is often needed to collect information from various locations, maybe you've got logs running on one host, you've got different services running on another, you're spending a lot of toil going between all of those different environments to collect this information. Centralizing your telemetry stream into a telemetry pipeline enables you to capture the insights that you care about and really reduce the amount of manual intensive exercises that you're using to try to collect that information to understand how your system is operating in real time. Again, we don't store the data, we simply pass it through our telemetry pipeline and then emit it out to your observability tools so that you can consume it that way. And so with that, I will go ahead and hop over. And I should tell you one more thing. Again, with that, we are able to build some insights. I'm going to show you the live version of this. So let's hop over to the demo. And so taking a look at the telemetry pipeline, let me wake up my browser here. Oh, there it goes. I just refreshed it. And so this is an example of a telemetry pipeline. Now, this is a little bit of a robust, let's call it, pipeline that has a lot of information, a lot of capability that's configured, but the ideas are simple. We followed that 5-step process, and we are basically ingesting our telemetry stream from a Kubernetes environment and through one of the sources that we have listed over here on the left-hand side. From there, it flows through a series of processors. And in this case, the first thing it does is we route telemetry based on what type it is. And so this first route processor looks and checks to see, is this a log event or is this a metric event? And based on what type it is, it follows a different path. And then as we flow through here, for example, logs, step 1 of the 5-step process is to drop the noise. And so what we're doing is we define a filter right here that looks for any conditions that match this particular message or this one, and just simply drops the event because it's just noise and we don't care about it. Now, we're in kind of a runtime mode here. So right now I can actually click on this button to tap the information that's flowing into this particular node of the pipeline. And if I expand this out, I can start to see in real time the telemetry flowing into this particular node. I can expand these out, and we started to talk a little bit earlier about how much of your events are actually information versus labels or attributes. And you can see this is the original log line that was logged. These are all the additional metadata fields that are being captured by the OpenTelemetry collector and tagged to this particular log line. So we have information about the cloud environment that we're running in. The Kubernetes information is also being captured, and then some of the OTel information as well. I can use any of this information to make decisions about how to filter my data, how to aggregate, how to sample, how to route. I have all of this information at my fingertips to actually define that before the data reaches its destination. And so just kind of following this logical flow here, you can see after we've dropped the noise, we send it to, let me expand this. We send it to another route processor where we're actually breaking apart the telemetry stream by service. And so for each of the different services that make up this microservice environment, I can actually take different paths and handle the information differently. So for example, I mentioned earlier that in my checkout or my payment service, we are seeing these credit card violations showing up. And so this is the real world example of how we actually implement that. We can view the configuration of this, see that it's using a regex to actually look for that information. And then the encryption, the metric generation, and then as the output flows from the processors, they ultimately reach their destinations. And in this case, we can send to any number of destinations that we want to. For metrics, we're actually sending them off to both a Grafana instance as well as a Datadog instance. And then for our logs, we're actually exporting those out to a Splunk instance as well as a Loki instance on Grafana. And so if I flip over to my Grafana dashboard, we actually have a dashboard that is assembled with information that came exclusively from the telemetry pipeline. And so all of the information here was not a metric that was being exported by the service itself. It's information that's gathered out of the log lines. And so you can see down here, we're seeing the ad recommendations by the particular product type. We can see the number of items that are being placed in the shopping cart. All of those different metrics that we are collecting are now being exposed on this dashboard. Likewise, because we have the ability to just emit a metric to any backend observability tool that you're using, we also have a similar dashboard created inside of Datadog that can visualize the same information in a different kind of Datadog specific way. There's other areas that are of particular interest inside the pipeline that you can do. We have another flow that basically takes all the log lines and showcase and basically looks for any words such as error or exception or these different negative sentiments. So these are like out of memory conditions or whatever it is that we want to track that we might classify as a negative sentiment. And we actually emit these as metrics so that we can visualize that on the dashboard. And then there's one other kind of interesting pattern that we can do here, that we take all of the container logs and then we start counting up the number of entries by either node or container. So let me show you what that looks like. So in this case, we're counting up the number of log lines by container, just creating an incremental counter. And we're emitting a new metric called log entry, and we're tagging it with the service name of the container. So now when we flip over to our dashboard, we can actually visualize that using a heat map. And so this heat map shows the number of services that we have running in our Kubernetes environment. And it's showing that, things like the Prometheus server, Grafana, Kube proxy, and so on, they're not too chatty. They don't have a lot of activity. But this cart service, being kind of red hot over here, is showing, the most activity over this particular last hour interval. And maybe that's something that's either running normal, or maybe I want to zoom out farther and see if that's something that's concerning to me. But I can basically do that data analytics from within the pipeline itself and emit something that's more useful to me. And then again, like those errors, exceptions, and negative sentiments that I mentioned, they can show up here on a dashboard as well. And then also we talked about that clear text credit card violation that will show up as a counter that maybe I want to define or assign an alert to, that will actually notify me that something bad is happening. So that's kind of the idea here, is that you're consuming your telemetry, ingesting it into a pipeline. You can basically edit this pipeline by simply going into edit mode. From here, you'll be able to add any source, processor, or destination. So for example, when I click on add source, you can see that I can pull data in from several different AWS services, from a Datadog agent itself. So it's not limited to just open telemetry collectors. You can use FluentBit. There's numerous ways to get telemetry in. And then I can add any number of different processors to actually process the information, things like filtering and parsing of the data, converting maybe unstructured formats into a structured format that's more meaningful. These are all available to me to operate on the data. And then I can send it off to any destination where I want that data to be utilized. And I can obviously send it to multiple destinations. So I could make changes, edit this, and then hit deploy, and that would deploy that running version out to the production area. And then at the top here, you'll see that we're just showcasing, for this particular pipeline, the volume of ingress data versus the amount of egress data. So again, the whole idea behind this was to optimize my observability investment. You can see that I've reduced my observability telemetry output from 1.25 gigs over the last 3 hours down to just 280 megabytes. So I'm only pulling out the data that's valuable to me and basically discarding the rest. Okay, so I think with that, we can go ahead and kind of talk through just kind of a quick recap. These are, again, the 5 steps to optimizing your observability investment. Filter out the duplicate and extraneous events, route data to long-term retention, trim those events, get them down to size, convert the events into metrics, and decrease the operational expenses. So just kind of as a recap, what have we seen? Well, we've seen the ability to eliminate the noise in the event stream. We've optionally made a backup copy of the telemetry data so that we can reference it again somewhere down the road if we needed to. We've trimmed some of the extra unnecessary labels and whatnot off of our telemetry. We've gathered business insights that might be particularly helpful to SREs that need to understand kind of how their applications or services are performing in a real-time approach. And then we've really made it easy to be able to visualize those insights. Information that was stored inside of a log line that might have just been lost as it's scrolled by is now kind of extracted and made in a more easily consumable approach. And kind of, like that's kind of the whole idea, is to really get better value out of your telemetry stream. So I think that with that, we'll go ahead and take some questions. And I'm going to take a sip of water.
All right, just making sure I am back with you guys. We did receive quite a few questions throughout today's program, so let's go ahead and just take a couple of these from the top. So what do you recommend to get started looking at telemetry pipelines?
So I think to get started, really you want to focus on a particular area of your business that is producing telemetry. You want to think about what the destination of that telemetry is. So pretty much most of the organizations have multiple telemetry tools. You really want to understand why you're getting started, what goals are you trying to accomplish, and then look at different ways to actually consume that telemetry, what you can do with it to accomplish the goals that you want to. We have tutorials and workshops that you can actually step through that kind of is a hand-holding approach to getting started with telemetry pipelines, building your own. And we also have a welcome pipeline that we're getting ready to roll out next week that will make it super easy to consume your own Kubernetes data within 5 minutes of getting started with a new account for trial or for free trial for free tier basis.
Awesome. Yeah. So kind of in that same vein, we just received a question that do we have any labs to try these pipelines? What would you say is their best way to get a hold of these labs or these demos?
Yeah, so we will be publishing a link after this webinar that you can go to that will actually enable you to sign up for a free trial. You can bring your own data, whatever data you want from whatever your source is, and you'll be able to push your telemetry and start playing around with how to actually consume that telemetry inside the pipeline itself. So we'll publish that link to all the participants of this webinar.
Awesome. Thanks for that. So you did say they can bring their own data. What sources can you receive data from?
So as I kind of highlighted in there, I can go back and show it. When I go in to edit this pipeline, I can add sources. And so we try to meet you where your data resides. And so whether you're using an open telemetry collector, which is fairly universal at this point, or more of a specific proprietary agent to collect the information, there's also sorts of different ways to actually ingest both from traditional Prometheus or log scraping techniques to something more advanced like pulling from Kafka or an SQS queue, something like that. So typically there's a common denominator between where the telemetry resides and the endpoints on our telemetry pipeline to be able to get that information in.
Awesome. We did get a question here. It says, can't open telemetry do much of this already?
Yeah, and so the idea behind the kind of the difference between open telemetry and the telemetry pipeline, those that are familiar with open telemetry know that it's really comprised of a series of receivers that you defined, some processors that kind of make up the pipeline itself, and then some destinations as to where to export that data to. The combination of receivers, pipeline, or processors and exporters really make up the entire pipeline. So it's kind of a localized version of a more global telemetry pipeline. This telemetry pipeline solves the problem of managing the otherwise problem that you would have of a fleet of open telemetry collectors. So managing open telemetry collectors at scale can be more challenging. There's different configurations that can exist per collector. Managing a fleet of those is a bit more complicated. With a centralized observability pipeline, all of your configuration is done here in the cloud. You can configure your pipelines, they're versioned. You can roll out controlled deployments of those different pipelines when you're ready. And it really promotes reuse. And so you can have a front-end pipeline that is your basic ingest pipeline that routes data off to other pipelines so that they can be consumed by the different teams that actually need that telemetry information. And so it's a much more manageable approach than what open telemetry is necessarily doing at the edge. It still has its purpose and its capabilities that are important, but this is kind of more of a centralized approach to management.
Gotcha. Yeah, all that makes sense. We do have one more question here that says, how can I later decrypt data that I've encrypted in your tool, and what key management is supported?
Yep. So there is a decrypt capability so that you can decrypt. You can basically define. You can pick whatever encryption algorithm that you want. You can supply your own vector, your initial vector, as well as your own key, and encrypt that data so that if you want to decrypt it at some future point, you're able to do that because you've got the key. We currently don't have an external key management capability, but the ability to supply your own key and your initialization vector is completely up to you.
All right, thank you for that. It looks like at this point, I'm going to roll into a couple of just larger observability-based questions that we've received. So why do you think observability is considered a critical factor in managing and maintaining complex software systems?
Because there's just too many pieces to keep your eyes on at one time. Services are becoming more globally deployed. More services are being deployed uh, to make up, rather than the monolithic environment, they have microservices. And then we also have to still operate with the existing core or legacy services that have existed for a number of years. And so keeping tabs on all of this is critically important, because when your business has a critical outage, your customers are impacted, and that can generate, obviously, that can result in lost revenue in the millions, depending on the type of operation that you have for every second that you're down. So, it's super important to be able to keep tabs on all of the different services that you have dependencies on, but that's also created the new problem, which is too much telemetry data. And so the need for these telemetry pipelines came about because of the complexity of the environment and the need to kind of make sure that the information that we are ingesting is valuable information and not just low-level, low-valued information.
Awesome. Thank you for that overview. Another question reads, as a data architect, I've heard about observability and I think it's great, but there are some risks about creating silos. Now, this attendee has spoken with some vendors that don't seem to know about observability and they don't understand why. But more so than data silos, there are many knowledge silos in the IT industry. So kind of taking all of this, how would you combat silos when it comes to observability and how that can bring those insights into an entire company?
Yeah, I mean, and this perfect use case was we were speaking with a CISO for a large university who has the need to move data around the university. It's comprised of about 30 different business units. And they had silos in each one of the different business units because they had their own transformation and mapping that they needed to do. There was no reuse, there was no sharing of that information across those different teams. Having a centralized platform where they can actually ingest that telemetry, transform it, reuse those transformations across all the different teams was super beneficial for them to be able to kind of streamline their operations. Now, specifically for breaking down observability, with silos within the organizations, it really comes to just collecting the information. It's not going to be a light switch approach where one day now all of a sudden you're using all the latest and greatest metric generation, events, logs, traces. It's definitely kind of more of a marathon that takes time. A telemetry pipeline can help bridge that gap so that services that are maybe not yet capable of producing native telemetry can still flow their log information through the pipeline, surface those insights coming from those services, and make them actionable alongside the newer, more modern services that are being developed with the newer approach using OTel to produce metrics and traces and so on and so forth.
All right, so we do have I have one question remaining in my bank. So to our audience, last call for any questions. It's not too late to get those in. But this is an important question that I've got for you guys. How do you charge for this?
So yeah, so earlier I kind of mentioned that we showcase up here the volume of ingress versus egress. And the approach that we take is that we're only going to charge you for the data that is valuable to you. And by valuable, we're talking about the data that you actually egress. It doesn't do you any good just to send your data to us and then, just kind of leave it sitting on our platform. It's the data that you're filtering and sending out the back end that is of value to you. So we only charge on egress. So in this particular example, over the last 3 hours, we have shipped in 1.3 gigs worth of data. We're only egressing 282 megabytes. So that's what you would get charged for. There's no complex pricing in terms of the processor type that you're using or the type of transformation that you're doing. It's a very easy to understand and comprehend format, which is just based on egress alone. So that's a great question.
Awesome. Yeah, thank you so much for diving into that. I'm not seeing any more questions coming in, so I do want to kind of put each of you on the spot a little bit here. So Kevin, I'll start with you, and then we'll come back over to you, Bill, to give you a second to breathe. So Kevin, if you had one final bit of information for our audience to really take home from this, what do you think that would be?
Yeah, solving the telemetry problem, putting it together for your organization is, critical. The one question was about silos. We're seeing that problem all over the place, and observability is only going to really be successful as a practice if we can share that information across teams, and if we can collaborate and make all of that cost effective and efficient. So we do see this as a big problem that needs to be solved.
All right, Bill, you want to take a swing at it?
Sure. Yeah, I'll take it from the technical aspect. Super easy to get started. We'll send out that sign up link. You can bring your own telemetry. We also make it very easy for you to just simply run a Helm chart as part of your sign up for a new trial. And that will actually pull in your own Kubernetes data without you really having to do anything beyond just a Helm install. And you'll see your telemetry flowing through here. You can add whatever kind of processor routing capabilities that you want, and just experiment around with the shape of your data. So it's easy to get going.
Awesome. I love it. It looks like we did receive one more question. So before I let everyone go, this attendee asks, if I send to multiple destinations, am I getting billed for each?
Yeah, so we charge on egress, as I mentioned. Typically what we find is that as telemetry is flowing into the pipeline, you are sending specific information to a specific destination. We've spoken to a lot of enterprise accounts. We've kind of heard the feedback that some teams within the organization, they use Splunk for their logs. And so it's easy enough to collect their telemetry, filter out their logs, and only send them to Splunk, and then the rest of them can go over to to Grafana or whatever the other logging tool is that they're using. So we typically find that you don't send full fidelity copies of both logs to both destinations, but certainly you can if you want to. It's typically routing the information that is needed by the team as it's needed. So that's kind of the way the model works. But we can have conversations about your specific requirements and talk through that.
Yeah, and it looks like we actually have another Mezmo rep here with us in the chat, and they said the pricing model is meant to price on value and not add to the cost of your observability spend. So Mezmo can consider ingress on a case-by-case basis if our typical model puts you upside down. Awesome. Well, Kevin and Bill, thank you all so much for joining us today. This has been such an awesome session with diving into the demos and covering observability from the top down. So thank you both so much for joining us today on Techstrong Learning.
Thank you, everyone.
Thank you.
So I would like to remind everyone that we've been recording this past 45 minutes. So you will be receiving an email with a link to access this recording on demand. Of course, you can also find this recording living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. We have drafted our 4 winners for our $25 Amazon gift card drawing, and they are James A., Brent K., Kathy H., and Shashaya P. So to our 4 winners, keep an eye out for an email from me coming in the next 24 to 48 hours to give you some instructions on how to claim that gift card. If you don't happen to see that email, check your spam folder just in case it happens to get filtered out. I'd like to thank Mezmo for sponsoring our program today. And to our audience, thank you so much for joining us. We really appreciate your time here with us. And we also really appreciate your feedback. So I posted a link in the chat a second ago, but I'm going to go ahead and post it again here. This link will just take you to our post-webinar survey. And also, if you just stick around with us through the closing, you'll get redirected to it. But we would love to hear your thoughts about our content today, or if you have suggestions for upcoming topics, please do let us know. Either way, we do hope to see everyone at a future Techstrong Learning experience. Have a great rest of your day. And Kevin, Bill, thank you once again.
Bye-bye.
Thank you.